talk about some 3D figures. So the basic 3D figures we're going to talk about in this class are sphere, cube, a cuboid, which is also called a rectangular prism. I just felt like including that fancy word there. In our work, we'll generally refer to it as a rectangular prism, just so that we can keep that prism title consistent. Cylinders, hexagonal prisms. Notice how rectangular prisms, hexagonal prisms, and triangular prisms are all just named for the shape of what we call the base. So if you're dealing with a base that is a rectangle, you've got a rectangular prism. If you're dealing with a base that is a hexagon, you've got a hexagonal prism. And if you've got a base that is a triangle, you've got a triangular prism. So let's say I drew a pentagon, and then I said, hey, I've got now a 3D shape coming off this pentagon. Well, guess what? That would be a pentagonal prism. We also have cones, and square-based pyramids and triangular-based pyramids. We're going to be considering all of these. First, let's consider this. It says, describe the characteristics of a three-dimensional figure formed by rotating the semicircle shown below about the x-axis. Okay, so we're going to be rotating this semicircle around the x-axis. So we'd rotate that part around the x-axis, and we'd rotate this part around the x-axis, and this part around the x-axis. We'd rotate all of these pieces around the x-axis. Well, what does it look like I'm drawing here? Well, if I was more talented, it'd be more obvious. This is a sphere. Okay, well, let's see this one. It says, describe the characteristics of a three-dimensional figure formed by rotating the triangle shown below around x equals 3. Now, if you look at your x-axis, we're counting by threes, 3, 6, 9, 12, 15, 18. So my x equals 3 is this line right here. So let's say I was going to rotate around that line. Make this as accurate as possible. We'd be going around. Now, because we're rotating, it would be nice curved edges. So we wouldn't be dealing with a pyramid here, because if we kind of were able to picture this for ourselves, there'd be a circular base to it and be round. So this is a cone. Describe the characteristics of a three-dimensional figure formed by rotating the rectangle below around y equals 3. Okay, so again, our y-axis is in threes, so 3, 6, 9, 12, 15, and so forth. So here's my line y equals 3. Now I'm going to be taking this shape, and again, I'm going to be rotating it around that point, that center of rotation. As best my drawing is, well, it's hard to kind of tell what that is, but if you look at it and you think about, okay, well, it's a circle on both ends. If you remember from before, well, it's got a circle on both ends. Oh, that's my cylinder. Okay, this one says, describe the characteristics of a three-dimensional figure formed by rotating the rectangular shown below around y equals 0. So y equals 0 is a horizontal line wherever y is equal to 0, which is also just called our x-axis. So if we rotated this around our x-axis, well, that would give us another cylinder. Now, let's talk about, instead of rotating shapes, what if we cut them? Much like using like a super cool geometry knife. And what we want to think about when we're cutting these shapes is what kind of a shape is made by the cross section. So let's do some investigation into this first one here. We've got a square base pyramid, and we've got this kind of, imagine this cross section that would be cut. And if we could actually like X-ray and see into it, it looks like it would make some kind of square. This one, we've got a nice rectangular prism right here. And as we cut it, looks like it would make a square as well. So we're getting a lot of squares so far. Oh, but now we come across this, alluded to earlier in the video, pentagonal prism. And as we cut this, well, wouldn't the cross section be another pentagon? Yeah, it would. Now that happens when we slice it horizontally, but what if we do a vertical slice? Well, if we slice this vertically, I'd end up with something like this. Well, that looks like a triangle to me, and indeed it is. What if I slice this vertically? Well, it still looks like it's got a lot of right angles to it, but it's obviously tall, so we're going to call that a rectangle. And then if we slice this horizontally, well, we're still just ending up with another circle. So let's go ahead and do some exercises like this. So it says the right triangular pyramid with the same orientation as the pyramid shown below is sliced by a plane parallel to its base. So the base is the bottom of it. So we've got, if I can draw this accurately, we've got this plane out in space that's going to be cutting through this triangular prism. So there's probably going to be a little bit of a part of it will be poking out the bottom, part of it will be coming out the top. It says, what shape must the cross section with that be? Okay, well, let's kind of imagine we did have some kind of cross section happening here, right around here where I've drawn this cut. Well, it looks to me like we have another right angle or right triangle. Let's try another one. This one's kind of hard to see what's happening here. We've got a triangular base, and it's been carried down into a prism. It says a right triangular prism with the same orientation as the prism shown below is sliced by a plane parallel to its base. Okay, so just like the last problem, where we took some kind of plane parallel to this base. And we've sliced it, so part of it's poking out the top of the plane, part of it's going out the bottom of the plane. We're asked, what shape must the cross section formed by this slice be? Well, the shape formed by the slice would be the same as the base of the prism. So again, we'd end up with a triangle. Okay, we got this. It says, what two-dimensional cross section could possibly be created by slicing a sphere either vertically or horizontally? So no matter which way we slice it, I'll just go horizontally for this example, but it doesn't matter because, you know, spheres are symmetrical on all sides. If we slice that up, then the cross section that would be left would be a circle. Hopefully you can kind of see the circle here that would be left. This one says a cylinder with the same orientation as the cylinder shown below. A straight cut is made perpendicular to its base. Okay, perpendicular means we've got a right angle happening here. Through its center, what must the shape what shape must be made by the cross section? Okay, so if we cut this kind of through this area, well, that wouldn't be round anymore. In fact, if we kind of could x-ray through this to see it being cut, that would be a rectangle. This one says a plane intersects the following square pyramid diagonally through one of the base edges and passes through the top vertex. Okay, so it's going to go through a base edge. It's going to go through a top vertex. Passes through the top vertex and will create a cross section that is what shape? Well, if I put a plane perfectly on this figure so that it could touch both those parts of the shape, that means it would just be touching this surface, meaning we'd have another triangle. This one says a plane that cuts through the following cube intersects the midpoints of EF. Okay, so here's the midpoint of EF, of AE, here's the midpoint of AE, and EH. Here's EH. All right, so it's got to intersect this. Oh, I know what kind of an intersection that is. That looks like a triangle to me. That's all for today.